Aliskiren is a renin inhibitor used to manage high blood pressure. This drug inhibits renin by binding to its active site, and renin is an enzyme responsible for the production of angiotensin 1 and subsequently angiotensin 2. Angiotensin 2 is a potent vasoconstrictor, so by blocking its action, Aliskiren works to lower blood pressure and reduce the risk of cardiovascular events in patients. On the right side of the molecule, we see a long ether chain. This chain connects to a benzene ring, and connected to the benzene ring is another ether linkage. Next to the benzene ring, we see an isopropyl group, and next to the isopropyl group, there's a primary amine, and next to that is the secondary alcohol. Adjacent to the secondary alcohol is another isopropyl group, and next to that, we see a secondary amide. Near the end of the molecule, there's a dimethyl group, and lastly, we have a primary amide. This drug also contains 4 stereocenters that give the molecule a unique shape and allow it to fit properly within renin's active site. Here we see the oxygen within the ether chain hydrogen bonding with a tyrosine residue within the binding pocket. Other oxygen molecule in the long ether linkage also hydrogen bonds, this time with a water molecule in the renin active site. The oxygen within the short ether chain also participates in hydrogen bonding with the same water molecule in the binding pocket. The benzene ring in Aliskiren participates in pi stacking with the nearby phenylalanine group in the binding pocket. Here's the first isopropyl group. This group is hydrophobic, so it engages in van der Waals interactions with the nearby hydrophobic amino acid valine. Next is the primary amine that's hydrogen bonding with the nearby glycine residue, as well as asparagine within the binding pocket. Adjacent is the secondary alcohol that participates in hydrogen bonding with the asparagine residue in the binding pocket. Here we see the second isopropyl group. Again, this substituent is hydrophobic, so it engages in van der Waals interactions with the nearby hydrophobic amino acids, leucine and isoleucine. Next up is the secondary amide. The oxygen within this functional group participates in hydrogen bonding with the nearby serine residue. The nitrogen atom within the secondary amide also participates in hydrogen bonding, this time with glycine in the residue. Lastly, we see the primary amide functional group. The oxygen within this group has hydrogen bonding interactions with water, and that hydrogen bond connects to glutamate and threonine residues within the pocket. The nitrogen molecule in the amide also participates in hydrogen bonding with the nearby arginine residue in the binding pocket. To make this video, I used the Protein Data Bank, MolSoft, and an article from the National Library of Medicine. Thank you for watching.